Are you okay? That first step is a doozy over there. Okay, 6.4, we're going to look at translated exponential graphs, okay? So this looks a little bit complicated. We're after graphing something f of x equal plus or minus b, f of x equal plus or minus b to the plus or minus exponent x plus c plus or minus d. Okay, that looks pretty complicated. We're going to break it down, and you're going to see what each of these pieces does, but we did the parent functions earlier, so some of this stuff should come back to you, okay? So we're going to start with the example that you see here, f of x equal 4 to the x, okay? You know how to graph that. Now, what would it mean if I reflected this graph about the y-axis? What would it look like? I'm going to give a graph of a function that reflects it about the y-axis. A negative where? Let's pretend like we've got a final exam in a couple weeks, and we've done this before, and it's where? Before the 4, just a negative in front of everything. So if I wrote g of x equal negative 4 to the x, that represents reflecting that about the y-axis, oh, this is where I'm confusing, so I'm getting you confused. Let me back up, sorry. Let me start with the x-axis, the one that you know. Sorry about that. Let's back up. Reflecting it about the x-axis. That's what you know. So g of x is equal to negative 4 to the x, okay? Anytime you see a graph to reflect it about the x-axis, you'll put a negative in front of that. Now, we did a graph yesterday, and there should have been some in your homework. What does it mean to reflect it about the y-axis? Where does the negative go? Right, the y, it goes in front of the exponent. So if I'm starting with 4 to the x, this is what reflects it about the x-axis. This is what reflects it about the y-axis, okay? So 4 to the x, we know looks like this. This function is reflected about the y-axis. It looks like this. This function is reflected about the x-axis. So if I reflect that about the x-axis, I get this, okay? So this is new, the reflection about the y-axis. So just by putting a negative in front of the exponent, I've reflected about the y-axis. So that's the only new transformation we're seeing here. All the others we've seen before. Now, what would represent shifting the graph up by 4? You add a plus 4 to the end. So this is g of x equal 4 to the x plus 4. That represents taking the function 4 to the x, moving it up 4. What is the horizontal asymptote for this guy right here? Yeah, y equal 4. So y equal 4 is the horizontal asymptote. What's the horizontal asymptote for these two? 0, okay? The horizontal asymptote is always the number that you see out here by itself. Here the number is 0, there the number is 0. Okay, what would it mean to take that function f and shift it vertically down by 4 units? Yeah, 4 to the x, what? Minus 4. In that case, what is the horizontal asymptote? Yeah, so y equal negative 4 is the horizontal asymptote. Now, just so we can remember as I scroll down, remember our function f of x equal 4 to the x. What would it mean to move it to the left by 3? Yeah, it's x what? I add or I subtract? I plus to go to the left. So it's going to be g of x equal 4 to the x plus 3. That moves it to the left by 3, okay? Remember on the x-axis, the horizontal shifts, I want to think the negative moves it to the left, but it's opposite. The negative moves it to the right, the positive moves it to the left. That's the same thing we did with our polynomials, okay? Likewise, what would it mean to shift this guy to the right by 3? Right, so that's going to be g of x equal 4 to the x minus 3, okay? So these are all the transformations that we know with exponentials. Only one is different, sticking that negative in front of the exponent. That's the reflection about the y-axis. So the others we've all seen before. So put a negative in front of everything, that reflects it about the x-axis. The negative in front of the exponent, that's the new one, reflects about the y-axis. Everything else we've seen before. Add 4, it moves up vertically 4. Subtract 4, it moves down vertically 4. If you replace the x with an x plus 3, that moves it to the left by 3. Replace the x with an x minus 3, that moves it to the right by 3. So we've seen all of these before. Now please note there's a correction here in your book. Let's read through this. The biggest mistake people make, other than the typos that your teacher did, when you're reflecting about the y-axis, so here instead of x it should say y, and you're performing a horizontal shift, so a reflection and a shift. So if I've got f of x equal 5 to the x, and g of x equal minus, and then note it's in parentheses, x plus 1, this represents a shift about the y-axis and a horizontal shift of 1 to the left, okay? For g of x equal minus x plus 2, we need to rewrite that. So I need that exponent to be in parentheses. So I'm going to write it as minus x minus 2. You see where that's the same thing? I'm just factoring out a minus 1. This means it's reflected about the y-axis because of that negative sign, but this negative 2 means it moved where? To the right, okay? So it means it moved to the right by 2, okay? So what I'm saying you cannot do this. You cannot say 5. You cannot say that that is a reflection about the y-axis and a shift of 2 to the left. This is wrong, okay? You can't say that. What you have to do, you have to write it like this. 5 to the minus, the entire exponent has to be negative here. This represents, this is a reflection about the y-axis, and this is a shift of what? 2 to what direction? Right, okay? So this is correct, and this is wrong, okay? So anytime you're dealing with a shift about a reflection about the y-axis, that entire exponent has to be negative, and then you inspect what you have, okay? So when you see something like this with a negative exponent, make sure you write it as a negative times everything that's in parentheses. And then you look at the parentheses and you can recognize that shift like we always did. Okay, that's the biggest gotcha in doing any of these. So let's take a few examples here. I've got f of x is 5 to the x, and then g of x is 5 to the x plus 1. Okay, has this been reflected about the x-axis? No. How do I know that that was not? There would be a negative where? In front of everything, okay? Has it been reflected about the y-axis? No. How could I tell? The exponent would go from here, the exponent has a positive sign, it would have to go to a negative sign, okay? Has it moved vertically? Up or down? It's moved 0 units. To move vertically, what would I look for? I would see like a +2 on the end of it. That would mean it moved up 2 or a -2. So the only thing that happened here is a what? a horizontal movement. It moved where? 1 to the left, okay? 1 unit to the left, okay? So this should feel similar in the ways we decoded the moving of polynomials and parent functions, okay? So again, my original was 5 to the x, so I'm going to write that just sort of here. What's the change from 5 to the x to the 5 to the x minus 1? What is the only change you see? Yeah, but like the transformation, I mean, it shifted where? 1 to the right. So that's a 1 shift to the right. None of the other things happened. Did it reflect about the x-axis? No. There would have to be a negative in front for that. Did it reflect about the y-axis? No. This would have to go from x to a minus x, and there was no vertical shift involved in that one. Okay? Looking at the next one. Was it reflected about the x-axis? Yes. And how do I know that? Yeah. I know that by looking at that negative sign right there. That tells me it reflected about the x-axis. Did it reflect about the y-axis? No. I would look for, here was my original. I didn't see any of the exponents change sign. Did it shift vertically? No. And did it shift to the left or right? 1 unit to the left. Okay. What about this one? Did it reflect about the x-axis? No. I started with f of x is 5 to the x. To reflect about the x-axis, there would have to be a negative in front of the 5. Did it reflect about the y-axis? Yes. How can I tell? Yeah. It went from 5 to the x to 5 to the negative x. That's a reflection about the y-axis. Did it go up or down? 0 units. Did it shift left or right? No. There was no shift to the left or right. Let's look at the next guy. So, has this been reflected about the x-axis? Yes. Okay, the reason I know that is by looking at that negative sign right there. Has it been reflected about the y-axis? Yes, I know that by looking where? Yeah, the negative in front of the exponent tells me that. Did it move up or down? It moved 2 down, okay? Did it move left or right? No. Did not the pick, but like there's someone who thought it moved. Did you figure out why it did not move? Okay. Okay, yeah. Yeah. To move left or right, that would be plus 2 or minus 2 in the exponent, which I do not see. Okay, let's look at this one. Now, there's the gotcha in here that I want to make sure of. Before I do this problem, what do I have to do? What do I have to do with it? I need to rewrite this as g of x equal minus 5. That entire exponent needs to be negative, okay? So I need to write this as negative what? Not x plus 1, x minus 1 minus 4, okay? In order to decode this, when I'm determining that it reflected about the y-axis, I'm going from, my original was f of x equal, what, 5 to the x. So if I'm going to reflect about the y-axis, I need to see a negative sign in front of the entire exponent, okay? Now I can read what happened, okay? So let's look at what's written in green. Did it reflect about the x-axis? Yes. And I know that by looking at the negative sign, which is right there. Did it reflect about the y-axis? Yes. And I can see that by looking at the negative sign you see right there, okay? Did it move vertically? It did what? 4 units down, and I get that information by looking at this piece right here. What's the horizontal asymptote for this guy? Y equal -4, okay? Did it move horizontally? Yes, it moved what? 1 unit to the right, okay? And I get that piece of information by looking at that x minus 1 there, okay? Like I said, the biggest key here is when you've reflected about the y-axis, you go from having a positive sign in front of your exponent to a negative, or a negative to a positive. But you got to make sure when you've got a negative in front of the exponent, it's in front of the entire exponent, okay? So here I had to sort of factor out a -1 to make this work, okay? Now let's look at this one. My original was f of x equal 5 to the x. Has this been reflected about the x-axis? Yes. So, and I can tell that by looking at what? The minus in front of everything. Was it reflected about the y-axis? No. Okay. Did it move up or down? Yeah. 1 unit up. Okay. And did it shift left or right? It did. 1 to the what? 1 to the left. I'm getting different answers. 1 to the left. Remember the x plus 1, my head wants to say, yeah, it goes to the right, but it really goes to the left. I don't know. How do you remember that? That's the way I do it. How do you just say opposites? Okay. Yeah. Somehow you have to go against, the verticals, the positive goes up, negative goes down. With the horizontal, you just have to remember it's backwards. So. Right. On the horizontal axis, it is opposite. Okay. So now, let's look at how to graph one of these guys. Okay. So I want to graph -5 to the x plus 1 plus 1. Okay. Now we've got a couple of choices of how to graph it, and I'm just going to leave it up to you to figure out how you want to do this. Okay. Remember how we did parent functions? We would just move like we had a parabola, we would move it, to the right 2, down 1, and flip it. Okay. We can still do that, but I feel like it's harder to do on these. I don't know why. I think it's harder to visualize. So let's look at what has to happen here. This is reflected about the what? It's reflected about the x-axis. It's been horizontally shifted what? To the left by 1. And it's been vertically shifted up by 1. Okay? So I can graph 5 to the x, okay? And then do all of those things and make it work. So let's look at 5 to the x. So that's one way I'm going to do it. So let's look at, if I were to graph 5 to the x, okay? So in graphing 5 to the x, I'm going to pick x equals 0, -1, and 1. So what's 5 to the 0? 1. 5 to the 1? 5. 5 to the -1? 1/5, okay? So if I graph these 3 points, so 0, 1, 1, 5, and -1, 1/5, somewhere right here, okay? What has to happen to those points? They need to get reflected about the x-axis, right? So that means instead of this point being here, it's going to be down here. And then what else does it have to move? To the left by 1, and then what? Up by 1. So reflected, it goes down here. Left 1, up 1. So that point right there goes over to here, okay? So to reflect it about the x-axis, instead of being at 5, it will be at -5, okay? And then move it to the left 1 and up 1, okay? This point is 0, 1. To reflect it, it's going to be 0, -1. And then if I move it to the left 1 and up 1, it is right here, okay? Does everyone see that? Okay? Then this point right here, this is what? 1/5. If I move it down, it's -1/5. Okay? And then if I move it to the left one and up one, then it's back to where it was at the 1/5 level, sort of right there. Okay? What's the horizontal asymptote here? Y equal 1. Okay? So y equal 1 is my horizontal asymptote. And then what this graph does is this. Something like this. Why what? Why did I go down? Okay, so to get from this function to this function, we have to reflect it about the x-axis, move it to the left one, and up one. So the original points, here's the original point. To reflect it about the x-axis means it's no longer at 5, it's at -5. And then to move it to the left one and up one, that's this point right here. Same thing here, 0, 1, move it to the 0, -1, left one, up one. Okay, now that's one way of doing this graph. Okay, the other way to do this graph is like we did where we just pick the points. Okay, in order to pick points, I want to find where this exponent is equal to what? 0. So I can say, when does x plus 1 equal 0? That's when x equals what? -1. So if I pick -1 and then pick the two numbers on either side of -1, what are they? Yeah, -2 and 0. Okay, the two numbers on either side of -1. So I can pick these 3 points and get that same graph. So if I do that, what is, and I go to this, what is -5 to the -2 plus 1 plus 1? So break this down. What's -2 plus 1? -1. So this is -5 to the -1. What's 5 to the -1? It wasn't a trick question. 5 to the -1. It's 1/5. Okay. So this is -1/5 plus 1. Okay, which is just 4/5. Okay. If I plug in a -1 into this equation, I get -5 to the -1 plus 1 plus 1. What's -1 plus 1? What's -5 to the 0? 5 to the 0 is 1. Negative is -1. -1 plus 1 is 0. Okay. And then if I do this one, what is -5 to the 0 plus 1 plus 1? What's 0 plus 1? 1. So what's 5 to the 1? 5. With a negative in front, that's -5. -5 plus 1 is -4. So the other way to graph this would be to go through that exercise. It doesn't matter to me how you do it. You got to be comfortable with your laws of exponents and your arithmetic to do this, okay? So -2 4/5, that's going to be somewhere, right here. -1 0 is here, and 0 -4 is here, okay? So you can see the graph does the same thing, and y equal 1 is the horizontal asymptote, okay? What's the domain of this function? Yeah, that's the same answer for every one of these exponentials, so don't miss that. What's the range? Where do I start to find the range? Down here, right? The range is what? -infinity to 1. The horizontal asymptote is y equal 1. Okay. Okay. So guys, that should be the end, I think, of where we are. What you should be able to do, you should be able to look at any exponential function and recognize when was it reflected about the x-axis? What is your clue that it's reflected about the x-axis? A negative where? In front of everything, okay? What's your clue that is reflected about the y-axis? Negative in front of the exponent, or the exponent change sign. Like for example, if you start out with 5 to the negative x, this one is reflected about the y-axis. So your sign changed on your exponent. What's your clue for a horizontal shift? The exponent is like an x plus 2 or an x plus 3 or an x minus 1, x minus 3. So if it's a plus, it moved to where? The left. If it's a minus, it moved to the right, okay? Vertical shift's pretty easy. What is that? Yeah, there's just a number tagged on the end of the equation. Positive number went up, negative number went down, okay? Also, this vertical shift tells you the equation of what? If there's a plus 7 on the end, what other significance is that? It's the horizontal asymptote, okay? And then, like I said, that's writing these and being able to look at these equations and decode all of the things that happen, okay? And like I said, the biggest gotcha is going to be something like this. So let's just do another one of these. F of x equals 6 to the x, and g of x equal minus 6 to the minus x plus 2 minus 3. Let's tell everything that happened in that equation, okay? Now, what you want to do is I recognize it went from a positive x to a negative x. I need that negative to be in front of what? The entire exponent, okay? So I need to rewrite this as g of x equal negative 6 to the negative x, and then what? Minus 2 minus 3. Okay, I need that entire exponent to be negative so I can decode it. Now, has this been reflected about the x-axis? Yes. So we know that it's been reflected about the x-axis because of that negative in front of everything. Was it reflected about the y-axis? Yes or no? Yeah, it was reflected about the y-axis. How do I know that? Yeah, it went from having a positive sign in front of the exponent to a negative sign in front of the exponent. And then what about the horizontal shift? Two units to the left, okay? If you did not factor out this negative sign, you would be tempted to say this is 2 units where? You would tempted to say that's 2 units to the right, okay? But that's not the case. When you put a negative in front of that x, you're reversing what you memorized with left and right. When you put a negative in front of it, you're flipping it. So that's why you want to put that parentheses. And then what was the vertical? Yeah. So the vertical was it went down by 3. Okay. So anyway, this, like I said, this should be fairly intuitive because you've seen this before. So you're going to see examples where I give you a situation and you write the equation, where I give you the equation and you tell me back what happened, and then an example where you graph something. And again, graphing, you can graph it from the transformation or you can graph it by finding the points. Okay?